Good morning, students. Today we will talk about molecularity, difference between molecularity and order of reaction, and pseudo unimolecular reaction. So let's start. Molecularity. Students, molecularity is the number of reacting species, that may be atoms, ions, or molecules, taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. What I mean to say, students, suppose there is a general reaction where A is converting into P, and as suppose this reaction is balanced. So what is molecularity? Molecularity is simply the number of reacting species. So here there is one reacting species, so for this type of reaction the molecularity will be 1. And suppose there is a reaction, that is AB gives C, and also suppose that the reaction is balanced, that is the reaction is chemically balanced. For this there are two reacting species A and B, so here molecularity will be 2. So you can again see that what molecularity is. It is simply the number of reacting species taking part in an elementary reaction. Elementary reaction means any reaction which take place in one step or single step. Okay, now let us see the example. Here you are seeing 2HI breaks down into H2 and I2. For this the reacting species, that is HI is 2, so the molecularity will be 2. And similarly for this reaction, that is 2NO plus O2 gives 2NO2. Here also, as there are 2 molecule of NO and 1 molecule of O2, so 2 plus 1 results in 3. So for this molecularity will be 3. This is the basic definition of molecularity. Now let's talk about some characteristic of molecularity. So molecularity of a reaction is numerical value. Okay, as order of reaction is experimental, the molecularity of a reaction is theoretical. It is only based on theory. There is no experimentation for this. Now let's talk about the second point, that is it may be 1, 2 or 3. That is molecularity of a reaction can be 1, 2 or 3. And let's talk about the third point, that is it may not be 0 or fractional, as order of reaction is 0 and it may be fractional, but molecularity cannot be 0 or fractional. Now let's talk about the very last point, that is it may not be greater than 3. You have to pay attention here, that is it may not be greater than 3. We will discuss about this in few minutes, but let's understood the classification of reaction based on molecularity. What I mean to say, you have seen here molecularity may be 1, 2 or 3. So let's talk about unimolecular reaction. So what are unimolecular reaction? Students, those reactions in which molecularity is equal to 1 are called unimolecular reaction. You can see here ammonium nitrite is converting into N2 and 2H2O. So what happens here, its molecularity is 1. Why? Because there is one molecule of ammonium nitrite. Okay, now so having molecularity 1, it is known as unimolecular. Now let's talk about the second one, that is bimolecular. So those reactions for which molecularity is equal to 2 are called bimolecular reaction. You can see here in the example 2HI breaks down into H2 and I2. So here also you are seeing there is 2. Okay, so its molecularity will be 2. Now the very third, that is trimolecular. So those reactions for which molecularity is equal to 3 are called trimolecular reaction. You can see here in the example 2NO plus O2 gives 2NO2. So here there is 2NO and 1O2. So 2 plus 1 becomes 3. So for this, the molecularity will be 3 and the reaction becomes trimolecular reaction. Reaction becomes trimolecular reaction. As earlier said, pay attention to this line that it may not be greater than 3. So students, the probability that more than 3 molecules can collide and react simultaneously is very small. So the probability of reacting of or collidation or collision between more than 3 molecules is very small. Hence, reaction with the molecularity 3 and more are very rare and slow to proceed. Okay. Now, as we have discussed about order of reaction and molecularity of reaction, so let's understood both of them having difference between them, because in your board exams questions are asked to differentiate between order of reaction and molecularity of reaction, or it may be asked to write a short note on both. So let's start. Difference between order and molecularity of a reaction. Let's talk about very first difference. Order of reaction is an experimental quantity. It is based on experiment, and molecularity can be calculated by simply adding the molecule of slowest steps. Slowest steps, you know what I mean to say, that is elementary step. Any reaction which take part in single step, so we will take the numbers of slowest step. Now let's talk about the very second difference, that is order of reaction can be fractional as well as zero, but molecularity of reaction is always a whole number, that is 1, 2 or 3. Now let's talk about the third point, that is it is applicable to elementary as well as complex reaction. That is, we can identify order for elementary reaction and complex reaction also, but molecularity, it is applicable only for elementary reaction. Okay, now let's talk about the fourth point, that is for complex reaction order is given by slowest step. Okay, if there is a complex reaction, then order will be given by slowest step, but for complex reaction molecularity has no significance. We cannot calculate molecularity of a complex reaction. Okay, so this is all about the difference between order of reaction and molecularity of reaction. Now let's talk about a point, that is pseudo unimolecular reaction. So what is pseudo unimolecular reaction? Pseudo, you means that may be false or wrong. So the reaction which follows first order, that is any reaction whose order is first but its molecularity may be 2 or 3, is called pseudo unimolecular reaction. You can see the example here. CH3COC2H5 plus H2O in acidic media, here it represents the acidic media H plus, gives acetic acid and ethanol. So for this reaction, when we will draw the rate expression, it is given as K concentration of CH3COC2H5 raised to the power 1 and H2O concentration of H2O raised to the power 0. So as what is order of reaction, it is simply the sum here. So here it is 1 and for H2O it is 0. So order will be 1. But as we have discussed about molecularity, so here one molecule is reacting with one molecule of water. So 1 plus 1 becomes 2. So for this reaction the molecularity will be 2. So this is pseudo unimolecular reaction. Similar is the case for pseudo first order reaction. A reaction will pretend to be of first order but it not follows the first order. So this is all about molecularity, classification of reaction based on molecularity, that is unimolecular, bimolecular, trimolecular, difference between order of reaction and molecularity, that is order is experimental whereas molecularity is calculated value, and now the pseudo unimolecular reaction. So this is about today's lecture. Thank you.